Hi, this is Algebra Set V Simultaneous Equations. So just a brief description, um, understanding of equations, okay? Yeah. So if an equation is given to you, x plus 2y is equal to 2, yeah? What does it represent graphically? Yeah. So on a graph paper, you have the y-axis, you have the x-axis. That is the origin out here with the coordinates x and y as 0, 0. So this equation on its own represents a line. Now, how do I know that? Because if I, let's just say, if I plug in x as 0, yeah, so 0 plus 2y is equal to 2 gives me 2y equal to 2 and y equal to 1. So I get y as 1. So for that equation, yeah, to draw a line, I need only 2 points. So the first point I got is x is 0, y is 1. So when x is 0, y is 1, this is the point I am getting, 0, comma 1. Yeah, x is 0, y is 1. This is the y coordinate. This is the x coordinate, like that. Understood? So let's take y as 0. If I take y as 0, then I get x plus 0 is equal to 2. So x is equal to 2. So my next coordinates are 2 and 0. Do not take it as 0 and 2, 2 and 0. Understood? So if it's 2 out here, and then y coordinate will be 0. So this is my 2, 0 point out here. So my line in the blue is this line out here. So this blue color line represents this equation x plus 2y equal to 2. Okay. Now let's take another equation. Let's say the equation is 2x plus 3y is equal to 6. So that also represents a line. So let's just take x and y. Yeah. Let's take x as 0. So if x is 0, then the whole 2x becomes 0. Plus 3y is equal to 6. Therefore, 3y is equal to 6 and y is equal to 2. So I get 0, comma 2. 0, comma 2 is this point. Okay. And now let's take, you don't have to take every time a 0. You can obviously take a different value. So let's take x is equal to, 2. Let's take x is equal to 2. Okay. So if I take x as 2, that is, if I take x as 2, then 2 into 2 gives me 4 plus 3y is equal to 6. So I get 3y is equal to 6 minus 4, which is 2. So my y is 2 by 3. Y is 2 by 3. So when x is 2, y is 2 by 3. So if this is 1, 2 by 3 somewhere here, yeah, so this is my point, and therefore my line becomes this one. So you might get confused now that, okay, he got the second point, but the second point 2 and 2 by 3. So 2 and 2 by 3 at the middle level of your schooling becomes a bit, you know, complicated to grasp. So that's the reason I take integer or whole numbers to work with. Anyway, so I've got my two lines now, green and blue. Now, if I extend the blue line and the green line, so let me extend the green line. Yeah. So I'll cancel the part again. I'll draw my green line. Yeah, I'll extend it. Okay. Yeah. And similarly, I'll extend my blue color line. Yeah. So that's my blue line. And if you notice that they intersect at a point out here. Now, this point most probably represents an x which is about 3, 4, 5, 6, and a y which is about 2. So this point I've got out here is 6 comma 2. So what is this 6 comma 2? So see, this is a freehand drawing. So the 6 comma 2, these values are not accurate. So in order to find an accurate value, let's solve these two equations. That is this equation in green out here, and this equation in maroon out here. Okay, this one. Let's solve them simultaneously. So I have two equations, x plus 2y equals to 2 and 2x plus 3y equals to 6. Yeah. So the first thing that comes to my mind, yeah, is using the substitution method. Substitution method. Yeah. Hang on. Huh? So in the substitution method, what I'm going to do is I'm going to use the first equation. I'm going to label them as equation 1 and 2. So from the first equation, yeah, what I get is x is equal to 2 minus 2y. So I make x the subject of the equation, and I substitute this x in the second equation. So my second equation is 2x plus 3y equals to 6. So if I substitute this in place of x, I get 2 times 2 minus 2y plus 3y equals to 6. So I get 4 minus 4y plus 3y. Yeah, that is 4. Yeah, y equals to 6. Yeah, 4 minus 4y, correct, plus 3y equal to 6. So then I end up getting 4 minus y equals to 6 because minus 4y plus 3y is minus y. And then finally I get 4 minus 6. Yeah, 4 minus 6 is equal to y. And so I got negative 2 is equal to y. So yeah, this out here is obviously negative 2. So I was pretty much accurate out here. Yeah. And so let's just say that I got the y accurate. Now let's see if I got the x also right. So now since I got the value of y is equal to negative 2, I'm going to substitute the value of y in the first equation out here. You can substitute in any of these two equations to get your answer. Yeah. But I'm going to substitute it in the first equation because it looks you know uh, less calculative compared to the second one. So if I substitute the value of y, yeah, so I'll use this out here, minus 2, y is equal to negative 2. So x is equal to 2 minus 2y gives you x is equal to 2 minus 2 into minus 2 because y is minus 2. So therefore I get x is equal to 2 plus 4, and yeah, I got an accurate value. So my freehand drawing was pretty much accurate to say. So what I ended up getting using substitution method, there are two methods, elimination and substitution. So I will solve this these two equations using the elimination method, right? But as of now, the criteria was to show you that x is equal to 6. Now, obviously, this last part which I'm writing might not show up on the screen, but any which way, what I wanted to show you is that um, that what is an equation? A single equation represents a line, yeah, right? And when you have two equations, yeah, when you have two lines, correct? Now, any two lines will always and always intersect at some point. If they do not intersect, that means those two lines are parallel. Now, I'm pretty much going to a higher secondary level of schooling topics out here, or the subject matter of the math content of simultaneous equations covered. is pretty much going on a higher level. So I'll just stop out here and let you know that equation represents a line. Two equations will always and always intersect unless they are parallel. So you can ignore the word parallel for the time being. Just remember that they intersect. Okay. Yeah. But there is a condition where they do not intersect. So we're not going to cover that part. Okay. So for the time being, two lines, they will intersect. The point where they intersected is 6 and -2. We found it out graphically. Okay. Right. So now when you solve your equation simultaneously, the value of x and y that you get is the other coordinates of the point of intersection of those two lines represented by those two equations. Make sense? When you solve the simultaneous equations, the two values x and y that you get are nothing but the coordinates of the point of intersection of those two lines represented by those two equations. As you can see, I've shown it to you graphically as well, and I've solved it using simultaneous equations substitution method. So now I'm going to solve these two equations using the elimination method. And remember, our values are 6 and -2. Okay. Now let me delete. I'm not going to delete. I'm just going to put a white screen on it, and I got the red screen. I'll put the white screen. I'm going to solve those two equations. So right now you saw the substitution method. Now we're going to use the elimination method. Okay. So in the substitution method, what we did was we made x or y the subject of the equation, right? So first we, according to the convenience factor, if you look at the equation one, it was easier to make x the subject of the equation because I did not have to divide or multiply anything to get x singled out. Like for example, in the first equation, if I were to make y the subject of the equation, then I would have to divide by 2 to single out the y, meaning I had to get rid of the coefficient 2 next to the 2y. And hence I chose to make x a subject of the equation and then substitute in the second one. That was substitution method. So we will be practicing. The worksheet is given to you to practice both the methods. So I'm going to use both the methods while solving these equations examples given to you, at least for 4 to 5 examples, right? So that was substitution. Now elimination method is also quite cool. Yeah. So in the elimination method, x plus 2y is equal to 2. 2x plus 3y is equal to 6. Yeah. What do we do? We try and make, the elements which are only x and only y of the corresponding two equations having the same coefficient. For example, in the first equation, x is x. In the second equation, x is 2x, right? So I'll try and make the first equation, the x part 2, so I can eliminate it. I can do the cancellation part. So let me show it to you what I mean. So I'm going to multiply the first equation by 2. That's the multiplication sign. So when I multiply the first equation by 2, I get 2x plus 4y is equal to 4. Got it? And now I'm going to use the second equation. I'm going to rewrite it. And what am I going to do? I'm going to subtract this equation. Yeah. Let's call it the second equation from this first equation. Obviously, this first equation is the same, but only thing is it's got heavier. It's got fact multiplied by 2 throughout, right? So it is the first equation, but now I can subtract the second equation from the first equation. So when I subtract the second equation from the first equation, the entire thing I'll have to multiply with a negative sign, the entire second equation, right? So I'll do some mental math out here. So I'll just put it down out here. So this was initially 2x, it became -2x. Yeah, this one will become negative and this one will become negative. So 2x minus 2x gives you 0. Yeah. 4y minus 3y becomes y. So remember, when I'm subtracting the second equation from the first equation, the entire second equation I need to multiply with a negative 1. So that's what I've done out here. So 4y minus 3y is y, and 4 minus 6 is minus 2. And this is using elimination method. And once you do this step, then simply substitute the value of y in any one of these two equations. So if you remember, I'd chosen the first equation to substitute the value of y, but this time I'll substitute it in the second equation just to show you that you will end up getting the same value 6. It doesn't matter whether you substitute the value of y in the first one or the second one. Okay, so I'm going to substitute it in the second equation. 2x plus 3y is equal to 6. 2x plus 3 times negative 2 is equal to 6. 2x is equal to 12 because this is negative 6 and that is 6. So they add up to 12, and x is equal to 6 because divide both 2 on both sides. So that was elimination method. Right. So now we have some pretty easy equations to solve. So what I'm going to do is I'm going to discuss at least 5 of them using both the methods, okay? And then I'll just stick to any one method randomly that comes to my mind. Okay, so we'll begin with the first 5 questions, as I said. I'll be doing both the methods, substitution and elimination, yeah? So let's look at the first equation. Okay, so I'll use substitution method first, short form sub, and then the elimination method. Okay. So I've got x plus y is equal to 5. X minus y is equal to 2. So you can use the first equation. Yeah. So I'll just call it first and second. Yeah. So from the first equation, I'm going to make x the subject of the equation. So I get x is equal to 5 minus y. And I'm going to substitute this value of x in the second equation. So my second equation is x minus y is equal to 2. Yeah. Now substituting the value of x out here. So I get 5 minus y is equal to 2. And therefore I get 5 minus 2, 3 is equal to 2y. So 3 by 2 is equal to y. So now I'm going to substitute the value of y in any of these equations. I'll substitute in the first equation. So x plus y is equal to 5. X plus 3 by 2 is equal to 5. Here's a substitution of y. So x is 5 minus 3 by 2. Yeah. So I know 3 by 2 is 1.5, and 5 minus 1.5 is 3.5. 3.5 is 7 by 2. So these are the values. Okay. I'll just bracket it. 3 by 2, 7 by 2. Elimination method. X plus y is equal to 5. X minus y is equal to 2. Okay, x plus y is equal to 5. So in the elimination method, we try and make the coefficients equals out here. I've already got the coefficient of x and y equal. Yeah. So usually I would say subtract the second equation from the first one. But out here, I can already see that there's 1 plus y and 1 minus y. So there's no need of subtraction. I'm going to just add them up. So I get 2x and a 0 is equal to 7. So x is 7 over 2, which is what I got, if you see. And now I'm going to substitute the value of x in the first equation. or the second equation, whatever you prefer. So I'll substitute in the first equation. Yeah, so the first equation is x plus y is equal to 5. So x is 7 over 2. 7 over 2 plus y is equal to 5. Therefore, y is 5 minus 7 over 2, which is 3.5. So y is 1.5. 1.5 is 3 by 2. And that's what I got out here. Matches. Okay, let's move on to the second one. So sub and elimination. Yeah. So first equation is x minus y is equal to 0. Second equation is x plus y is equal to 3. So I'm going to substitute the value of the first equation, the second one. So clearly I can see that making x the subject of the equation gives me x is equal to y. Substituting that in the second equation gives me, so now I'll substitute x is y, so y plus y is equal to 3. 2y is equal to 3, y is equal to 3 by 2. So I'm going to substitute the value of y in the first equation, but as you can see, from the first equation, we know that, you know, x is equal to y. So I'll end up getting x as 3 by 2, but I'm just showing you the steps. So x minus 3 by 2 is equal to 0. X is equal to 3 by 2. Yeah, that was easy. So out here, the first equation is x minus y is equal to 0. X plus y is equal to 3. Again, no need of subtracting, no need of multiplying any equations. It's just minus y plus y, add them up. So you get 2x is equal to 3. X is 3 by 2. Substitute x in the first equation. Yeah. Okay. So you get x is 3 by 2. So if you notice how I got value of y first out here in the substitution, now I got the value of x in the elimination method. Uh, so the order doesn't matter really. It just depends on, whether you make y the subject of the equation in the substitution method or the x, and then accordingly you're using, you're substituting and getting the answer. So out here also, it just doesn't really matter. Okay. Yeah. I mean, I could have solved the same equation by subtracting, you know, the second equation from the first equation, and I would have ended up canceling out the x and getting 2y. Just to explain you what I mean is that if I were to do subtraction, although it's not required, it would be uh, not smart to do subtraction when you already have a ready-made equation in front of you. But just to show you that if you were to subtract the second one from the first one, it wouldn't matter. It would give you the same answer. So now I'm subtracting the second one from the first one, which means that I'm multiplying -1 to the second equation. Yeah. So that's negative x, negative y. Yeah. Is equal to -3 because you're multiplying negative. Because when you're subtracting the first from the second one, you're basically multiplying -1 to the entire equation. So whichever is plus becomes minus, minus becomes plus. So out here, the entire second equation is positive x, positive y, positive 3. So everything becomes negative. So now we simply add them up. So this cancels out. You get -2y is equal to -3. So y is equal to 3 by 2. Negative, negative cancels as here. And then when you substitute, you know x is equal to y, and you'll get the same answer as x is equal to 3 by 2. Okay, third equation, C. Yeah. Sub elimination. So first equation is 2x plus 3y is equal to 4. Second equation is 2x minus 3y is equal to 1. So as you can see, I've intentionally made it easy where you don't have to really multiply like I showed you in the the first half of this video. So it's ready made in front of you. You don't need to subtract the second from the first one. You simply add them. Yeah. So if you add them, you end up getting 4x and the 3y and 3y cancels out. Yeah. Is equal to 5. So 4x is equal to 5. So x is equal to 5 by 4. Now substitute the 5 by 4 in any one of the equations. So I'll substitute in the first one. Yeah. So 2 times 5 by 4. That dot out there is not a decimal dot. It's just a multiplication dot. Yeah. Plus 3y is equal to 4. And then that is, 5 by 2 plus 3y is equal to 4 because this 2 cancels with this 4. So 5 by 2. 5 by 2 is 2.5. So 3y is 4 minus 5 by 2. So 3y is 4 minus 5 by 2. 4 minus 2.5 is 1.5. 1.5 is 3 by 2. So 3y is equal to 3 by 2 divided by 3 on both sides. So y is equal to 3 by 2 and a 3 down here. So I end up getting half. So y is equal to half. Substitution method. Now elimination method. 2x. Oh, my bad. I think I by mistake did the elimination, yeah, instead of substitution. So yeah. So that is the default way your brain functions. Yeah. Uh, what ends up what you end up doing is once you become proficient, yeah, once you end up becoming proficient at solving, it naturally comes to you to solve it using the right method or the easier way to solve an equation. So that's what happened with me out here. I ended up using by default, I ended up using the elimination method, yeah, when I should have used the substitution. But I'll do the substitution now out here. Yeah. No, my bad. Okay. So in this one, I'll again use the make x a subject of the equation from the first one. Therefore, I'll divide 2 throughout. So I'll get x is equal to 4 by 2, which is 2, minus 3 by 2y. Okay. So it's not a smart move to use substitution for this question because it's just going to make your calculations harder. Okay. So I got x is equal to 2 minus 3 by 2y. I'm going to substitute this value of x in the second equation. So x is 2 times 2 minus 3 by 2y, and then minus 3y is equal to 1. So 2 times 2 is 4, and then minus 3 by 2 into 2 is minus 3y. Okay. Minus 3y again, which is equal to 1. So I get 3 is equal to 6y. Yeah. 4 minus 1, 3 is equal to 6y. So 3 by 6 is equal to y, and that is half is equal to y. Got it? Now to each his own. I mean, whichever method you prefer, you know. Some might say that substitution was not as hard as you said, and so I prefer the substitution. So it's up to you, man. D. Now, if you look at D, it's quite easy. What they're doing in D is simply, the y is given to you. Yeah, the value of y is given to you. All you have to do is substitute it. So anyway, I'll do both the substitution and the elimination. Simply substitute the value of y in the first equation. So 4x plus y is equal to 7. Now I'm substituting the value of y as 3. 4x is equal to 4, x is equal to 1. Now substitute x in obviously the first equation only because there is no x in the second equation. So therefore 4x plus y is equal to 7. 4 times 1 plus y is equal to 7. Y is equal to 3. Easy peasy. So come to think of it, do you need to solve for y? No, because y is 3 given to you in the equation. So all you have to do is just solve for x. Yeah. But then I'm just following the steps. Elimination. Okay, so I've got plus y here. So now I'll have to subtract the second from the first one. So when I subtract, it's negative. Everything positive becomes negative, negative becomes positive. So I get negative y and negative 3, and I'll simply add them. So 4x is 4, x is 1, and that's about it. You don't need to really solve it because you got y is equal to 3. But I'll solve it anyway. Got it? Okay, right. E. Now come to look at it, E, both the equations are identical. Why are they identical? Because if I multiply the first one by 3, yeah, I will end up getting the second one. If I divide the second one by 3, I'll end up getting the first one. So if you see, when the equations are identical, they are overlapping lines. If you understand the first half of my video, equation is a representation of a line on the xy coordinate plane. So when two equations are identical, like the way it's given out here, right? Okay, it the points are going to be on the same line, so they're just overlapping lines, or you can say it's the same line, and therefore there is no solution for this. As I'll show you, I multiply the first one by 3, and so my first equation is the same as the second one, and everything cancels out, right? So now I'll subtract the second from the first one, so everything positive becomes negative, and negative becomes positive, and 0 is neutral, so I end up getting 0, 0, and 0. Nothing to work with. There are no x and y values. So, what can you say about this? Can you say that there are no values of x and y? Or can you say that there are infinite values of x and y? Yeah, any value of x and y you can take. What can you say about this? Well, what you could say is that this is how I can explain it to you, that from the first equation, x minus y is 0, which represents x is equal to y. From the second equation, 3x minus 3y is equal to 0, which represents 3x is equal to 3y. In other words, x is equal to y. So you could say that the solutions for these equations, yeah, simultaneous equations, would be any value of x and y provided x is equal to y. Any value of x and y provided x is equal to y. So I would love to stretch on this point and show it to you graphically that I'll just show it to you graphically that on the xy coordinate plane, yeah, it would be a straight line passing through the origin like this. All right. And this red line will have all the coordinates on it where x and y are equal. So suppose it's 4 and 4, 2 and 2, 0 and 0, -2 and -2. Yeah, -4 and -4. So I'll take -5 and -5. It could be any value x and y would be the solution as long as x is equal to y. Got it? Yeah. And elimination, as you can see, uh, if I multiply the first one by 3, yeah, or if I divide the second one by 3, in elimination also, they just get cancelled out. I think what I've done is, again, again, I have by default used not the substitution method, but the elimination method. My bad again for that, but as you can see, I've used the elimination out here and not the substitution. So let me use a substitution and show it to you what happens, okay? So the first equation is x minus y is equal to 0. Second equation is 3x minus 3y is equal to 0. So now, excuse me. So now x is equal to y from the first equation, and I'm going to substitute the value of x in the second equation. Okay, so I'm going to substitute the value of x as y. So I get 3y, yeah, minus 3y is equal to 0. So that is, yeah, so that is 0 is equal to 0, or 3y is equal to 3y. I mean, you know, basically it just shows you that the left hand side is equal to right hand side, yeah, and you get infinite values. That's it. And those infinite values are such that x is equal to y. Excuse me. Okay, right. Now I'll start solving f, g, h, I, j using any method that comes to my mind. So let's begin. So obviously, the method that comes to my head is substitution because x is -4. I'm going to substitute. So 7 into -4 plus 4y is equal to 4. That's -28 plus 4y is equal to 4. So that's 4y is equal to 32. Y is equal to 8. Okay. All right. I already got x equal to -4, y is 8. So I'm not going to substitute y equal to 8 in the second equation. not required. Okay, so that's your simultaneous equation solved. X and Y value G. Okay. X is equal to Y. So substitution again, actually not required, because as you can see, the first equation doesn't have X at all. So I'll just solve the first equation and I get 9y is equal to 27. So y is equal to 3. And that's about it. I know that substitution is not required because I know from the second equation x is y and y is 3. So x is 3, you know. Or you can just substitute. So, y is 3. So x is equal to y from the second equation. So x is equal to 3. Pretty easy. Okay. H. Thirteen x plus 7y is equal to 450. Y is equal to x plus 30. Yeah. So I'll use substitution method, right? So I'm going to simply substitute the value of y in the first equation. So 13x plus 7 times y, which is x plus 30, is equal to 450. 13 times x plus 7x plus 210 is equal to 450. That's 20x is equal to 240. 450 minus 210 is 240. Okay, 0, 0 goes. All right, so I got 12. 2 goes in 24 12 times. You're right. So now I'm going to substitute the value of x in the second equation. So y is equal to x plus 30 becomes y is equal to 12 plus 30, and I got y is equal to 42. Yeah, easy. I and j. I'll use substitution again. I'm going to substitute the value of y in the first equation. So from the second equation, I'll make y the subject of the equation. Okay, now I'm going to substitute the value of y in the first equation. And I do my substitution. 2 times 4 is 8 minus 6x. So that's 14x is equal to 8 plus 76. That is 84. And 4 5s are 70. 14 5s are 70, sorry. So 14 6 are 84. So x is equal to 6. Now substitute the value of x in the second equation or the first equation. So I'll go with the second equation. X is 6 and Y is negative 14. All right. J. This one's going to be a 1 hour long video, definitely. So J looks difficult, but it's actually easy because if I divide 7 throughout, yeah, if I divide 7 throughout, then I end up getting x plus y is equal to 6. So now I can make uh, x the subject of the equation and then substitute it in the second equation. And I'll substitute the value of x, which is 3 times 6 minus y is equal to 7. That's 18 minus 3y minus y is equal to 7. Yeah, that's 18 minus 4y is equal to 7. So 4y is equal to 18 minus 7, which is 11. So y is 11 by 4. I'm just working on the calculation again. Yeah. Okay. So I get 11 and 4y. So yeah, everything's right. So now I'm going to substitute the value of x, y in the first equation. And the first equation simplified to x plus y is equal to 6. Okay. So this is 4 twos are 8, 8.75. But I'm just going to do the regular, solving for this one, right? I need to make the denominator 4, yeah, for this one as well. So what I'm going to do is, therefore, x is equal to multiply the first part by 4 and divide it by 4. So what I end up getting is 24 by 4 minus 11 by 4. So which is, I'll just take it up here, 13 over 4. That's my value of x. Got it? Because when the denominator is equal, you simply subtract the numerator or add them, whatever the case may be. So out here, it's subtraction. That's 13 by 4. Okay. Okay. So the simultaneous equations that you came across is, you know, it justifies the middle school level. Um, Ideally, there would be difficult or tougher simultaneous equations as you, move ahead to grade 9, 10, 11, 12. Right. So now what we have is a simple solving for x, equations given to you. So let's see how to solve them. Okay. These are not simultaneous equations, but this is something that would be required to understand algebraic equations, understand them better. Okay. A. You got x plus 4 on the top, x minus 5 at the bottom equals to 4. So all we got to do is multiply both sides by x minus 5. What I mean by that is we simply take the denominator portion and take it to the right hand side, yeah, in bracket. So that's the step. When I say multiply both sides by x minus 5, I simply mean take this on the right hand side that way, because that would naturally happen if I were to multiply x minus 5 on both sides like this. So this and this would cancel and you end up getting that step. So yeah, right. And then simplify it. So you got x plus 4 is equal to 4x minus 20. And then you get 24 because 20 would come on the left hand side. Yeah, is equal to 4x minus x, which is 3x. And therefore you get x as 8. B. X plus 2 upon 3 is equal to x minus 2 upon 3. So the best way to simplify this is multiplying 3 on both sides. So when you multiply 3 on both sides, you end up getting this. And then you realize that the x's cancel out. That is x minus x is equal to minus 2 minus 2. So you got nothing. Yeah. The left hand side is not equal to right hand side. And hence, there is no value of x that would satisfy uh, the expression which is given in B. So when you solve for x, there is no value of x that will satisfy this equation. Got it? Yeah? Okay. Suppose left hand side was equal to right hand side, then there would be all values of x. Anything. Negative values, 0, positive values, fractions, everything under the sun, other than imaginary numbers. So what are imaginary numbers? Well, again, higher levels, not now. Meaning not in this middle school level. Yes, there's something called imaginary numbers as well. Right. Yeah. Yeah. See, 2x plus 2 upon 4 is equal to x upon 4. Again, simplify this expression by multiplying 4 on both sides. Yeah. Which gives you a simple equation like this. And that is nothing but x is equal to negative 2. How is that possible? Subtract x on both sides, so you get x out here, and then subtract 2 on both sides, so you get negative 2 on the other side. So you've learned this drill in the algebraic algebra sets A, B, C, D, E. D. X plus 4 upon 5 is equal to 4x minus 12 upon 4. So this time we're going to multiply, we're going to simplify this expression, right? How do we simplify this expression? Um, by getting rid of the denominator 5 and 4. So how do you do that? Yeah, we simply multiply 20 on both sides because 20 is a common multiple of 5 and 4, right? Yeah, so that's one way of doing it. Yeah, and I don't want to get into the other way because unnecessarily I'll have to then use these disclaimers that there are limitations and other things. So let's just go ahead and solve it the right way. Multiply 20 on both sides. So if you multiply 20 on both sides, yeah, this is what you get. That 5 I've taken below 20 for simplification of the calculation. And similarly, I've taken 4 below the 20. And this is what you end up getting. So 5 goes in 24 times. So you end up getting 4x plus 4. And 4 goes in 25 times. So you get 4x minus 12. Simplify it further. So you get 76 is equal to 16x. Right. Okay. Right. So now 76 is a multiple of 2, and so is 16. So you divide 2 on both sides. So you get 38 is equal to 8x. 38 is a multiple of 2, so again divide by 2 on both sides. So you get 19 is equal to 4x. And then finally, the value of x that we get is 19 over 4 is equal to x. So that's your answer for the D. Yeah. Hmm. E. 3x plus 2 upon 8 is equal to x minus 2 upon 8 is equal to 0. So there's no equal to out there. It's a negative sign. So there are two ways to solve this. Because the denominator is 8, yeah, you can simplify the entire expression this way. The numerator simply gets added, but you got to be careful if you're adding or subtracting the numerator. So out here is a negative sign. So put a bracket, okay? Because what happens is minus x and then this minus outside. So treat it as a bracket. Understood? So that minus outside multiplies with minus out here inside and becomes positive. So when you put a bracket, it simplifies the whole thing. So you end up getting 3x plus 2 minus x plus 2 is equal to 0. 3x and minus x is 2x plus 4 is equal to 0. 2x is equal to negative 4, and therefore x is equal to negative 2. So the other way of solving this was taking this negative value onto the other side. So you'd have ended up getting 3x plus 2 upon 8 equals to x minus 2 upon 8. And then you could have multiplied 8 on both sides. So let's work it out here, out here. So suppose it was 3x plus 2 upon 8, yeah, minus x minus 2 upon 8 is equal to 0. And you take the negative 1 on the right hand side, then this is what you end up getting. Yeah. So multiply 8 on both sides. So you end up getting 3x plus 2 is equal to x minus 2. So 2x is equal to negative 4 and x is equal to negative 2. Yeah. Whatever you prefer. I think this method is better because it will save you from this red portion, the bracket part, which you might just forget that you got to bracket it, meaning you might end up just writing minus x minus 2, and that would change the entire value of x. So it's up to you. Anyway, F, G, H, I, J is equal to 3x plus 8 upon 3. Now, yes, you got to multiply by a common multiple of 9 and 3, and that is 9. So you multiply 9 on both sides. Yeah. So when I multiply 9 on left hand side, I get 4x minus 8. And when I multiply 9 on the right hand side, I get 9 over 3, which is 3 times 3x plus 8. Got it? Yeah. Okay. It's like 9 out here and 9 out here. So 3 goes into 9 three times. So you end up getting this in bracket, this part. This and this cancels. So you get this part. Anyway, right. Hmm. So simplify this further. And then I'm taking 4x on the right hand side, so I get 5x here. Yeah. And then 24 on the left hand side, I get negative 32. Mm. So that's negative 32 equal to 5x. So x is equal to negative 32 by 5. You can write down your answer as a mixed fraction as well, but that's not required. So it'll be negative 5, 6 are 30, 205, mixed fraction. Okay, G. 5x plus 23 upon 7 plus 3x minus 7 upon 2 is equal to 10. Okay, so this time it's not equal to 0. There's another number. So what you can do is multiply by a number which is common to 2 and 7. So why are we multiplying by a number which is common to 2 and 7? Yeah, or a multiple of 2 and 7 is because we want to simplify an expression by getting rid of the denominator. So obviously we are going to multiply by a multiple of 2 and 7, which is 14. Yeah, it could be 28 also if you wanted. It could be 140 also if you wanted. It could be any number, but we are trying to simplify. So we are trying to take the number which is the least common multiple, right? So the least common multiple of 2 and 7 is 14. So I multiply 14 throughout, what I end up getting. So this time I write down 14 because it's not just two expressions, it's the third 10 out here as well. So you might end up making mistakes. So this is what we get: 14 by 7, 5x plus 23, plus 14 by 2, 3x minus 7, and then 14 tens are 140. I'll just put that in bracket like that. So 7 goes into this, so I end up getting 2 times 5x plus 23, and then 2 goes into 14 7 times, so I get 7 times 3x minus 7, which is 140. So that is 10x, and that gives you 46, and that is 21x, and that is minus 49 is equal to 140. So 10x and 21x is 31x, right? And then 140 plus 49 and minus 46. So what's the right way? The right way is you add up the positives and then subtract the negative. Yeah. But that was when you were doing your algebra sets A to whatever. So right now the idea is to work smart. So the smart way is 140 and just subtract 49 and 46. So you end up getting plus 3. And that makes your life easy. It's 143. And now figure out if 143 is a multiple of 31. Yeah, I don't think so. It's a multiple of 31 because 34s are 120. Yeah, and then 35 are 150. So I don't think so. It's multiple. So that's about it. There's nothing common out here. Hmm. Yeah, nothing common. So therefore your value of x is you divide 31 on both sides. So you end up getting 143 by 31. H. Okay, so between 2 and 30, the common multiple is 30, 60, 90, and so on. So we are looking at the least common multiple. So that's 30. We multiply 30 throughout. So what we end up getting is 30 by 2, which is 15 times 4x minus 2, minus 30 and 30 cancel. So you got, put it in bracket, 3x plus 2, which is equal to 30 times 1, which is 30. So that is 60x minus 30, 15 4 is 60, yeah. And then minus 3x and minus 2, which is equal to 30. Right. So 60x and minus 3x is 57x. And then you got 30 plus 30 plus 2. So 57x is equal to 62. X is equal to 62 over 57. I and J. I. 4x plus 21 upon 3 is equal to 3x minus 12 upon 45. So multiply by the least common multiple of 3 and 45, which is 45, because 45 is the multiple of 3 as well. So 45 over 3 is 15 into 4x plus 21 is equal to 3x minus 12, because 45 and 45 cancels out. That's 60x. And then 15 times 21 is 15 ones are 15, 15 to the 30, 31, 315, 3x minus 12. Yeah? Okay. So 60x and 3x gives you 57x, and that is negative 12, negative 315. So 57x is equal to negative 3, 2, 7. And as you can see, 5 and 7, these digits add up to 12, so it's a multiple of 3. And these 3 digits add up to 12 as well. It's a multiple of 3 as well. So you can divide both sides by 3, and you do that, you get 19x is equal to minus 109. Correct? And 19 5 and 95, you add another 10, 105, you add a 9, 114. So 19 does not go into 109. So therefore, your value of x is 100 minus 109 by 19. And the last one, J. J, I'll just solve it out here. So you got 9x minus 5 upon 7x minus 6. So 9x minus 5 upon 7x minus 6 is equal to 3. So multiply 7x minus 6 on both sides. So you end up getting 9x minus 5 is equal to 3 times 7x minus 6. 9x minus 5 is equal to 21x minus 18. And then I'm going to take 9x on the other side and 18 on this side. So you get 18 minus 5 is equal to 21x minus 9x. That's 13 is equal to 12. 12x. Yeah. So 13 by 12 is equal to x. Divide 12 on both sides. That's your answer for J. And with that, we are done with this long, difficult, complicated worksheet. Simultaneous equations. Next one is going to be as long as this one. And it's going to be as difficult as this one. It's quadratic equations. Thank you, and you can always access the worksheet from the link given in the description of the video. Thank you.